Go ahead.
Yeah, so I would like to share my screen. Uh, so is this visible to you?
Yes.
Yeah, so before going into the problem, like what the problem is, so I would like to discuss about the CSR representation because that is the core of this problem. But although I had given the like all the templates and everything, like CSR representations, like were already given, but I found that there are so many mails regarding the confusion that why we are using reverse, like reverse CSR, right? Reverse offset array. So here I will not discuss the reverse offset array. Here I will discuss the offset array. So here, so just to be like to be very clear. So when we say offset array, that means that we are counting that how many neighbors for the particular node are there, right? And the neighbor list will consist of those neighbors of the particular node. So that is the meaning of offset array, I guess. Okay, so what is the meaning of reverse offset array? It means now in that how many in that also we are counting the number of nodes, but in this we are counting the incoming nodes. In the offset array thing, we are counting the outgoing nodes. So there is a small difference between this. Okay. So if you will see this graph, input graph, we have four nodes, one, two, three, and four. And so here here you can see that this is the CSR representation of the graph. In this way, we have offset array and coordinate array. That is the neighbor list, which neighbors are closer to the which neighbor are connected to the particular node. So for node 1, we can see that the node 4, node 2, and node 3 are the neighbors. So firstly, we calculate the offsets, like how many nodes, total number of nodes are the neighbors of the particular node. So for one, there are three nodes which are neighbor. So we will set the offset to 0 for the node number 1. And then what we will do, we will add we will count it. So the count is 3. So 0 plus 3 is 3. Now for node number 2, how many node is neighbor? So only one node is neighbor. Therefore 3 plus 1 is 4. For node number 3, how many nodes? So it's only one. Therefore 3 plus 1 is 4. And for node number 4, only for node number 4 there is nothing. So we will leave it like that. 5. So see, in the similar manner, we have to do this offset array calculation for other graphs also. This is a sample graph that I took. So now if you what you have to do now, you have to find out the neighbors, that which neighbor is which is the neighbor of the particular node. What we have to do, we have to traverse this offset array, and we have to see that which is like for this we will traverse from 0 to 3, excluding 3. So which all are between 0 to 3. So it will be 0, 1, and 2. It means whatever the nodes are pointing, like by 0, 1, and 2, that are the neighbors. So in the graph, you can see that 2 is the neighbor, here 2 is there, 3 is the neighbor, 3 is there here, and 4 is the neighbor, so 4 is there. So up to 2, we have to go, and 2, 3, 4 are the neighbors of the node number 1. So in this similar manner, this is done, and this is the CSR representation of the graph. So this is offset array and this is coordinate array. And for the PageRank algorithm, we also require this uh, reverse offset array. So what you have to do that just uh, for the count in this you are counting the outgoing edges. In that you can just count the incoming edges. That's it. There's no much difference. So okay, so this part was already on like this part was given. So there is like nothing to change in that. So so this is fine for all, right? I can proceed further. Okay, so I'll proceed. So our problem statement was like we have to calculate the page rank value for all the nodes. So if we have four nodes, then we have to calculate the page rank value to all the four nodes. So and I have defined that page rank of pi is equal to 1 minus d upon n plus d is the damping factor here, which we have set as 0.85 here in the question. So, and this summation Pj from MPI and PRJ divided by LPJ. So that is already defined in the question. What is PRJ? So PRJ is the old value of the page rank, and LPJ is the is the out degree of the node. Okay, so this is very obvious. I guess some of the people were getting some confusion that. So I guess this was very obvious, and it was doable. The problem would have come for the calculation of diff part, where we wanted faster convergence, right? So in that also many people did that. I saw some of the solutions, but this should not have caused any kind of problem because this was very obvious calculation of page rank. So what you have to do, you have to calculate this and you have to put it in the. There was some array node PR, something was given in already in the question. You need to just put copy this value to that. That's it. But if you will see the code, I guess I have to go to the code because I guess is this visible?
Yeah, visible.
So if you will see the do while loop, this part. So here, what we are doing that we are just checking the iteration count. So iteration count is initially 0, and we are increasing it by 1, and we are saying that it should be less than max iter. So we can do this much only, right? So suppose we are taking the maximum count is equal to like 100 or whatever we will fix it. So suppose we fix it 10 or 20 or whatever, but for our purpose we have fixed it 100. So it should have went 200 times. Sorry. So just a minute. Sorry. So to get rid of that it is going 100 times. So for the faster convergence, we want that it should converge a little fast as compared to what it is there. Like for it can go to 100, right? So we took a beta as some delimiter, and we are just checking the value of diff check, which is coming from GPU after some computation, which I will tell you what computation is that. And like we have to check whether this is greater than beta or not. That's it. And both conditions should come true. If anyone doesn't come true, then it will terminate. So this is the main thing in that how you will calculate this beta, sorry, this diff check. So since I have given this code, I think uh, there was some clue, right, that we have to calculate this for the faster convergence, right? So if I would have not given this diff, then there would have not any clue that whether you have to do any kind of calculations on the diff in the GPU or not. So you might have done this formula calculation and you have done it, and you have run the while loop with iter count less than max iter. That's it. So that will also work, but at the same time, there might be some slightly difference. Running performance difference will come because it will run for 100 times and now it will run for four times, 5 times. Will depend upon the test cases. So some performance to get the performance gain, we used to do like that. Okay. So now I will go to once again the formula that is there inside this. So in this, uh, what we have to do is that we have to uh, so we have to calculate the so how PageRank works is that for the particular node initially we initialize all the nodes with some some value, right? So suppose we have 4 nodes in the graph, we will assume that the PR value for the each node will be 1 upon 4, that is 0.25. So initially the value will be this, and after that, after each iteration, we will recalculate the value of the PR based on this formula, right? So so firstly we will calculate this part, right? PR PJ divided by LPJ. So that means that what is the old value of the PR value? That is 0.25 divided by LPJ, means how many like outgoing nodes are there. So in this offset array will come into picture that we will count. So how many nodes outgoing, for a particular node, how many outgoing neighbors are there. So for that, if you will traverse through or you will do a subtraction with the two offsets of the offset array, you will get that count of the neighbors, right? So that's very easy. And PR PJ will be that uh, that is the old value that you will get it uh, from the initialization itself. So this part is pretty clear, right? PR PJ by LPJ. And after calculating this part for all the nodes, it's all about the all the nodes. It's not about single nodes. After calculating for the one node, what we will do? We will do the uh, this part 1 minus d upon n. So 1 minus d is 0.85 upon n is total number of vertices divided by v plus this part. And this part is what? This part is sum is equal to sum plus this calculation, right? So any problem, whatever I told is like, are you able to visualize it, or should I make a like I should take a graph and from there I should uh, go through you by taking one example, uh, because there was some guy, right, who mailed me regarding that he was facing some problem that why in the question some out degree in degrees are used. I guess that is a standard way of calculating the page rank value. I guess that is required. Sandeep Chekla is something.
So, so here they told that this link to PA, right? So here the link is in degree of PA, in neighbors of PA, right? Is it like?
So that is that we are using for the calculation, right? So the for the particular node A, we are only seeing the in degree, right? But like how important the node is A is, for that we have to see the importance of the other nodes also, right? You understood, right? So
Yes.
in that we have to calculate the value of the other nodes, that how relatively how important is other nodes. So for that, I guess you have to calculate that, and that is there in the formula itself, right? So I should,
Sir,
yeah.
uh, whether this M of PI is the set of in neighbors of PI, because I I think that is right because then only we can use this source list because the source list contains the in neighbors of the index which we are considering. So
Correct.
can I assume that m of pi is the in neighbors of pi?
M of pi, right?
Yes, sir.
Yes, yes, yes.
Okay, sir.
So in this formula, do you have any problem? Like, I should I draw a graph and take the values, and should I take it like as a dry run for one iteration or two iteration, or is it fine? You can understand that how I am telling you. Is it fine for you all? Okay, should I understand that it is fine, or should I take one example? You can just tell me. Otherwise, I have to go. I think it is clear for all. So I will not take one example of the graph, and I will just reiterate this same statement again so that it should be pretty clear that what we are actually doing. So to calculate this P of I, there are two parts. First, we will do the calculation of this part. So where we are multiplying this D, that is damping factor, with summation of this. So firstly, just assume that D is not there. What we have to do? We have to do the summation Pj belongs to MPI, PRPJ divided by LPJ. So we have to do this part. So what we can do, we will calculate this part first, and after that calculation of this part, we will do 1 minus d by n plus d into this summation wala part at the in the next statement. Okay, so some uh, one thing I have faced that is not corresponding to the problem when I used grid.sync on P100. It was not computing anything after that barrier, and even after that, all value. Okay, okay. So let me tell you that if you will write the simple nvcc like a.cu enter, like in this way, it will not work because there is a particular SM requirement for that, and you have to use that SM70 and RDC equal to true for this to work. G.sync will not work for all the SMs, so you have to be a little aware about this, and I have already given in that so that you should not worry and search on the internet that what you have to do. I have already given that how you have to run it. If you will see at the top of the helper like CU file, uh, I guess somewhere it is there. I have put that so that you should not search it. So is it fine, Soumik? Have you tried? What command did you try? Okay, so you tried NVC RDC equal to true, SM equal to 70, and even after that also it's what not working. Okay, if you are doing this and things are not working, then I get there might be some problem in your code. Like then I have to see your code that what you have actually written. Yes. Yeah, Chinmay, could you elaborate how to calculate the diff in the kernel? Yeah, that is the important thing, which for the faster convergence. Yeah, I will tell you. Okay.
So, uh, sir, you have given an API, right? This like cooperative group. Uh,
Yeah.
I would like to mention that the document in the documentation it is given you have to use a different API. I have actually I think we have to like you have told that to use cooperative group and like the API is different. I want to. Uh,
Which what is that API?
yes, sir. I have mailed it. One second. Sir, it is like you have to use grid. Okay. we have to launch the kernel in a different fashion. It is been told in the documentation. If you want to do the grid sync, then you have to launch the kernel in a different fashion. The API could have launch. It is the like we have to launch the kernel in a different fashion, sir. Actually,
I
like
see. But as far as my knowledge is concerned, I guess I have done this in the past, and we are just using the cooperative group, and then we are just making a one instance of this, and then we are calling g.sync. That's it, and it is working fine for like I have tested it for the large enough graphs, like big graphs having millions of nodes. So that is working fine.
so, but whatever API you have given, and if you do g dot size, we get the size of the group, right? But the size of the group is not matching to the entire number of threads,
Uh,
because the group size shouldn't the group size should match to the total number of threads, like number of threads the grid is currently having.
uh, this I am not aware about grid.size, and I have not witnessed this in past also, so I cannot comment. We can just learn about this over the email, right? So for the current point of time, I can tell you that this g.sync works, and it is a global barrier. You can take it like that, and it is proven that it will not give you any incorrect result. I can assure you, but it is like it has some performance degradation. We have found while doing experimental results that when we have used g.sync, then in that case there is a performance loss, but we are not worried about the performance loss in this assignment. So that's why I told that we have to use global synchronization, because you have already studied in the last class about synchronization, and that was the motto behind this assignment. Okay, so that CUDA launch cooperative. Okay, so you are saying that we have to launch it in this manner, CUDA launch cooperative kernel, and that is inbuilt thing, right? That is CUDA launch cooperative kernel is from some header, right?
Yes, sir.
Okay, so we'll discuss it like offline, because this grid dot size equal to 4. I am not aware about this. That what is why this size? What is all about this size? Okay, so I will just since many people will submit code. I am very aware about this, because this is a trend from the last two assignment. So discussing the code will be a little difficult, but already I gave the all the clues that how you have to do this calculation uh, by this formula. I already gave clues, so I guess if somebody new will submit assignment, then they will find something more easier. For the calculation of diff, I can also tell. Rupesh, should I tell the calculation about diff and this thing? Because many submissions will come as expected. Okay, so base is not here. Okay, so most of the time, okay, let me discuss the code itself, because even though it will be so, like what we have to do, we have to just we have to write a for loop which will go to the reverse offset array, and it will take the neighbor, and it will do sum is equal to sum plus value of the this is the value for the initial PR value, and divided by that number of outgoing nodes. So this is similar to this line number 37 is similar to what? This line number 37 is similar to your this part, right? So you can relate with the formula. So PRPJ divided by LPJ. So this is similar to that. And now what we have to do, we have to multiply this with D and we have to add 1 minus D by N. Now what we can do is that after this we can put a G barrier because we are using some here like uh, it could cause race condition. So no, before going to race condition, just focus on formula itself. So now we calculated that part PRJ divided by LPJ. So now we have to add damping factor. So line number 45 will give you that. So 1 minus delta by V plus delta into sum. So delta is the damping factor, that is 0.85 we have already taken. And so in this way you got the result, right? So val you got, and you can put it line number 48, you can see inside the GPU PR node we can put the value of the val. So you are done. But
Uh,
the main, yeah, please.
yes, sir. So you said like double buffering. So I took what read buffer and write buffer. So after
Double
each exception,
buffering. Okay, I will see the solution. No problem. If you have done double buffering,
so
I
like I
told
take a
I
write
told
buffer.
over the email that you can use double buffering, but the motto behind was not double buffering because we are in the last lecture you might have studied about synchronization, and in the
Mhm.
question PDF it is given that you have to use global synchronization,
Yes, like but in the mail
and
you mentioned, so that's why I used.
everything is given in the form of uh, keeping synchronization in the mind, I guess, because I was telling about rest condition. Okay, no problem. I will go through the assignment and uh, we can decide it. But in the PDF, it was given that you have to use global synchronization. Anyways, so we can just consider it. Okay, so up to this part, any problem? Like it's very obvious from the formula, right? So we should not go here and there beyond the formula. So what after that you have to do? This I calculated a temporary variable, and that value is the what is that? So this is the new page rank value. This val is what? This val is a new page rank value, and this GPU node PRID is the old page rank value, right? So I calculated uh, a diff, not diff. I calculated a difference between these two numbers. So what is the difference between the new page rank minus the old page rank value, right? And I stored in some temp. And now what I will do, I will add this diff. So diff is initially 0. So I will add it to, so this atomic add means that diff is equal to diff plus temp. So diff value will be updated with this temp value, and we will copy back this diff value to the CPU, and inside that we can use that in the form of like convergence. Now you understood, right, how we have to calculate the value of diff and why we are calculating the value of diff. So that do while loop was the clue that like you have to calculate some kind of diff on GPU because I am doing CUDA mem copy from symbol. We are putting diff inside the diff check, and we are calculating diff check with the beta. We are comparing it. So I gave the solution because I guess 30-40 mails came yesterday for this calculation part, which was uh, okay. So any further problems, because now time is 9:30 and I am over with my time. So I guess I have discussed solution this time also, like irrespective of that, many people will submit it after this. And yeah, so any further problems, or I can disperse and the pace can take it. Okay, I guess there is no solution to pace.
Yeah, there is one question from Chinmay that says he has not calculated the diff.
Oh, I didn't saw because I was there. Okay, I have not calculated the diff. Would be this be considered? Okay, so if I will match. So for the test cases purpose, I will not run it, right. I will use the my script thing. So I guess it will go more iteration. The results should may vary. Like I'm not really sure. It might be for some decimals or something will like that. So I have given some like what do you call as error percentage that we are considering in our assignment. So already I have mailed yesterday about this, that what error percentage 0.0001, I guess something we have to do. So I will run that Python script. I already gave for you convenience so that you should not feel that how I am doing these all things internally. So it was very, I put it so that it should be fair enough so to understand that how the assignment evaluation is done. So in that part, I will just run it and we'll see whether it is coming correct. So I guess it should come. Uh, my guess is that it should come same only, but the performance will decrease. But that is not the worry for us. So, but since what I will say that since I have given it in the template, like already, if it is not given, right? So if diff is not given, CUDA main copy from symbol is not given, then I guess if you are doing iter count less than max iter, and you are not writing and comparing it with the beta, then diff with beta, then it is fine, I guess. But I guess I have given it that in the while loop that you have to compare it with the beta also, that diff is necessary. Uh, we will discuss this, but since it was given, we are also copying it back from GPU to CPU. So that was the motto behind the problem. But anyhow, okay, we will talk. What is the name? Chinmay Rajesh. Okay. Please, you can mail me, right? I will just see your solution once and we can discuss. Okay, so what you are, okay, you are also not done, right? So whosoever has not done this calculation, you can just drop me an email, right? So I will just look at a solution and we'll discuss it. Okay. Okay, any further